Hello, and welcome to helpyourmath.com. Today's video, we're going to be discussing the chain rule, right? And working out some problems so we can see the clarity in it. This is for Calculus 1. So here we have 4 problems of f of x, and the first function of x is x cubed. The second function is 2x to the power of 3 inside parentheses. The third, we have 2x squared plus 5 in parentheses to the third power. And the fourth, we have negative 2 times 3x cubed plus 5x in parentheses to the power of 2018. Now, the first problem doesn't look much like a chain rule, but I'm using the power rule here for a good reason. I'm using the power rule because the chain rule operates almost exactly like the chain rule does. And it's good to see how they're correlated to each other, because the more we see how the power rule works, the easier the chain rule will get, right? And just as a reminder, I'm going to just list the function of the power rule right up here. So when doing the power rule of taking a derivative of anything with an exponent to the power of n, what we're doing here is we're bringing down the exponent, multiplying it times the original function to the same power and subtracting 1 to that power. And so these are going to be the steps we take to find f prime over here, the function's prime. So the f prime of this function is going to be 3 times the original, x cubed, take away 1 to the power. Now if we subtract 1 to this power, we're going to be left with x squared. So here we have f prime of x is equivalent to 3x squared. And that's our first function. Moving on to the second equation, we have 2x to the power of 3, all inside of parentheses. And so here we're going to take a look at how this functions exactly like the power rule. Now before I begin, we notice that we can just expand this, right? And before I get into the chain rule, I'm going to expand this and derive it just how I did this with the power rule, so that we can have something to compare to the actual chain rule formula. Now the chain rule's formula is this. We have d to the derivative of a function that's not in terms of x, which we call u. And to take this derivative, what we're going to do is we're going to bring down the exponent the same way we do with the original power rule. We're going to multiply by the original function minus 1 to the exponent. And this, instead of just ending right here, we're going to multiply it times the derivative of the u function, which we call u prime. And that's the difference between the chain and the power rule. So here, if we want to see the clarity and the correlation between the two, I'm going to first expand this. So 2 to the third power is going to give me 8, and x to the third power gives me x cubed. So here, if I'm finding the derivative of this term, I just have to bring the exponent down, multiply it by the original equation, subtract 1 to the power. 3 times 8 gives me 24, and here I have x to the second power. So here we see that this is the derivative, right? And to reinforce how the chain rule works, I'm going to take this as my solution and try to get it right off of the original equation here. So I'm taking my original equation, and I have my f of x is equal to 2x's to the power of 3. And I'm going to bring the exponent down, right? The exponent comes to the front of the equation, so I have f prime of x. I get 3. The function stays the same. We have 2x. We have a 3 here. We're subtracting 1 to the power. And the final part is, whatever the inner function is, we're going to find the derivative of the inside and multiply it times the result of this. So the derivative of 2x's, right, is just going to be 2. And so let's multiply all this together and put it together again, and we have the f prime of x. It's going to be 3 times 2 gives me 6. Then in parentheses here I have a 2x. The exponent is 2. Now it doesn't look the same yet, right? Because I have 24x squared here. I have 6 times 2x to the second power. But let's expand this, right? So if we expand this, we're going to get 4x squared inside. So now we have 6 times 4x squared. When we multiply this out, we get 24x to the second power, which is the same exact result we got. So the rule again for this is we bring down the exponent, keep the inside the same, keep the power the same, subtract 1 from it while you're doing it, and multiply by the derivative of the inside. Now this is pretty useful because we don't always get a problem so simple. If we take a look at number 3, we can't just expand this without having to go through the triple expansion. So the chain rule adds that benefit to the mathematics while we're doing it, right? It helps us get a shortcut to the solution, and once we get to that shortcut, we're pretty much done with it. So let's take a look at this next problem. So here we have 2x to the second power plus 5 to the third power. Everything in the parentheses. So here to get the f prime, bringing down the exponent, we get the 3 out front. This stays the same with the same number up here. We get 2x squared plus 5. Subtract 1 to the 3. And we're going to multiply this by the derivative of the inner function. The derivative of 2x squared is going to be 4x's. The derivative of the 5 is just 0. So for the sake of the 5, I'm just going to put the plus 0 because the derivative of a constant is always 0. Now let's simplify what we have left over. So we have f prime of x. This is 3. Here we have 2x squared plus 5. The exponent here is now 2. And this is just 4x's. So we can go ahead and take this 4x and multiply it by the 3 and leave it in the front. This we do not have to expand. We can just leave it there. There are going to be cases where you have an exponent you cannot expand. So this is fine for the solution. Also, when we get to this point and we have 12x's here, this is perfectly factored and set up to solve. So if I set this equal to 0, it would be no problem. I have it exactly as I want it. All right, and this is the solution for this problem number 3. Let's move on to number 4, which is probably the more difficult of these problems, right? We have a really high power. We have a number in the front with a coefficient. We haven't seen a problem like that yet. And we have an inner function with 2x's this time. So the derivative of this function then, we're going to bring the exponent to the front of the problem. We get 2018 all the way in the front. And inside here we have a negative 2. This is going to stay the same. So we have 3x cubed plus 5x's. The exponent here is going to be 2018. Take away 1. And now we're going to multiply this in here by the derivative of what's inside. So here we're going to have times. The derivative of 3x cubed is going to be 9x squared, right? 3 by 3 is 9. The exponent of the cube, we subtract 1 to it. That becomes a 2. And over here we have plus 5x's. Now the exponent on the x is 1. So we bring the 1 down, multiply by the 5. That gives us a 5. And the x goes to the power of 0, which means it goes to 1. So it just goes away, right? Not the power of 1, but it becomes a 1. Anything to the power of 0 is just 1. And that's what's happening when we subtract 1 to this power. Now here's what we have. So what we have to do, we're going to keep these two as factors, but these two we're going to multiply them together. So we can have just one number, and we're going to simplify this exponent. So we have f prime of x. This becomes negative 4036. And here we're just going to line these up right next to this. I'm going to bring this one to the front of it and keep this one in the back with the higher exponent. All right? Actually, we'll just keep it in the same lineup. 3x cubed plus 5x's to the power of 2017. And here we have 9x squared plus 5. And that's our solution. Thank you for